Hi, very much on this side. So today I'm going to discuss about my HD task. This is basically about the QAC protocol. It is a modern transport protocol which is developed to overcome the limitations of the TCP. Okay, so as it sounds like quick means faster. So it's actually make the internet connection faster, and it is developed by the Google to improve the speed, reliability and security of the internet connection. Basically it's work over the UDP, and it is having encrypted TLS 1.3, means that we don't have to establish a different handshake like in TCP like TLS 1.2. The handshake is encrypted in this security is encrypted in it, means TLS 1.3 is basically encrypted in it, and we don't have to make a different handshake for it. So basically what is QAC? QAC, it is a protocol to make proper communication between the devices of a network. Basically now what is protocol? Protocol is a actually we use protocol to make proper communication between the devices over a network. So now one of the important and modern protocol is QAC. It is a modern protocol and specially designed to communicate faster, as we have discussed earlier. So this, and it uses HTTP3. This is basically developed. It is also the foundation of HTTP3. This we will discuss further. Now basically we will discuss history of development of QUIC. QSCs were developed in 2012 by the engineers of Google, and and in 2021 it became an official internet protocol, and QUIC is to improve web performance and security. Now what is the need of QUIC? The need of QUIC arises because traditional protocols like TCP were no longer enough to for the modern web users. Like we have to firstly for establish a connection, and we have to establish three-way handshake in TCP, and then for the security we have to establish a TLS also. Then it increase the round trip time, which means high latency. High latency means uh, it will take more time for the connection. It will consume our more time. For establishing connection we require multiple handshakes like this for security, and also the quick QAC is more secure because it is not compulsory for TCP to have TLS always, but in QAC the protocol the encryption is always there. It means security will be always there. And also it uses TLS 1.3. It is a modern uh, encryption, basically advanced version of TCP 1. TLS 1.2, and it's also reduce some weak algorithm of the overcome some weak algorithm of the TLS 1.2, means it is more efficient from TLS 1.2. So this is the point, like, and like also TCP when we try to connect change our network connection, if a file is downloading it will stop downloading, or there will be a interruption. There will be a interruption or error in the downloading the file. So this problem also solved by QIC. Head of line blocking, basically in TCP if one packet is lost, then the all the packet behind him have to wait for that particular packet to be found. Like you can imagine like there is a post office, okay, and if the one letter is lost, then all the packet which all the behind packet have to wait for that particular packet to be found or retransmitted. So basically this is a delay in the time that why the other packet behind him are waiting for that one particular. So this problem is also solved by QAC. The problem are it reduce the latency, integrate security directly, improve the reliability, and eliminate the head of line blocking. Now working of QAC. Now let's understand the working of QAC. We can see this. It is a hybrid protocol because it's having speed of UDP, and as it adds security and reliability features of TCP. So we also can say that it is a hybrid. It is a hybrid protocol, means as we know that UDP doesn't need any handshake to be established, and but it is also not reliable. So it is very fast. So it uses speed of UDP and reliability of TCP, means it is also having inbuilt encryption, means it is very secure also. Now connection establishment. For as we have discussed earlier in the TCP and TLS, we have to establish firstly three-way handshake. Then for TLS, one more round. It will increase the round trip time. But in the QAC, there is only one RTT because it is having inbuilt encryption. Or we can also in some cases we are having zero RTT. So now how this zero RTT possible? It is possible when we are having connection just instant, means just instant, means before we are having a connection, so we don't need have to again establish the connection. We can directly transfer a packet. It means that the client can send data server very in very first packet in the case two have previously conversation very recently in the past. Now packet structure. It retransmits packet. Now, take a thing like if we are sending a packet and I doesn't and these the sender there is sender receiver. The sender doesn't get a acknowledgement, so then it will retransmit the packet because it will think that the packet is not the packet doesn't reach to the destination, so it will retransmit the packet. Now the acknowledgement come. Now the sender will be confused that which acknowledgement is there, is this of the retransmitted one or the previous original packet. So to solve this problem, what the QSC does, it give a next higher number. It means if one packet transported, it will get a number, the second, third, fourth, it will get a number, and if the packet is retransmitted, it will get a next higher number. It means there should be no confusion, or the sender can identify easily that which acknowledgement is there, is this of the retransmitted one or the original one. Stream and multiplexing. So this is also one important innovative part of QSC, that it can handle different stream of data at the single connection, as we have this we have discussed earlier also. Connection migration with connection IDs. So here, so in TCP the traditional, there will be four tuple handshake. Like for first we have we are having source IP, source port, destination IP, and destination port. And if we switch from Wi-Fi to 4G or Wi-Fi to 5G, our file will get interrupted and downloading will get interrupted, or it will kill the connection. But what QoS does, it give a unique connection ID. Even if the IP address changed, the connection ID is same, so it will recognize you instantly, and the file will keep downloading. Means there should be not any interruption or any error between the downloading when we are downloading the file. Rich feedback. It means when when we send in TCP, when we receive acknowledgement, it will be like this, that I received the packet from 1 to 50. No, actually, it will get that I have received the packet up to 100. It will be like this in TCP. Now to identify the lost packet, it will be difficult, or it will consume more time for the sender to find the retransmitted packet, the lost packet actually. But in QSE, what it does, it say I have received packet 1 to 50, 60 to 100, but 51 to 59 are missing. So it will provide a complete map of received and missing packet, which will also means which will beneficial for the sender to recognize the lost packet. This, yes, pluggable user. Actually, TCP is a kernel based, means it is inbuilt in the operating system. If we want to do any particular updation or any single updation, for that we have to update the operating system whole over the world, and it will take a very it is very long process. It will take very uh, years to be it will take very year to do a single change. But but what is QSE? QSE basically it is a application implemented, but it implemented in the application only, user space only, and the user or developer can directly modify QSE without doing any changes in operating system. So it is also called pluggable algorithm, which means you can you can swap or improve them anytime. Now packing and burst. The TCP, as we know, the TCP sends the packet in bursts, and while QSE having solution for this also, it uses pacing, which means it sends the packet evenly over the time, like the steady flow, not the sudden flow. Now applications of QSE. QSE is foundation of HTTP3. HTTP3 is basically HTTP3 is not optional. It is basically uh, it is specially made for the QSE, as it built on the top of UDP and to achieve the low latency and better resilience. Now HTTP3, the most widely used application QSE is HTTP3. This is latest version of web protocol which standardized by the Internet Engineering Task Force. It was designed to overcome the major limitations like the HL blocking, as we discussed earlier, as we discussed earlier also, that the previous packet were blocked, and video streaming in real time. Actually here the QIC provides smoother viewing experience, especially in the mobile devices, by reducing the buffering. Because QIC is a faster, help to establish zero RTT, means the video start playing sooner. And these all things we have discussed earlier also. Yeah, IoT. QS is rapidly increasing in the field of IoT. Actually, IoT devices require low bandwidth, and it is low bandwidth, and the QAC is perfect, or you can say, or we can say, fully efficient for these IoT devices which require low bandwidth and small amount of data, because they require small amount of data quickly, and they have to return to the low power state to conserve energy also. This is the comparison table between the TSCP and QAC. Yeah, you can see in TCP firstly we have to establish this three-way handshake, then TLS, and here only one RTT. Here two RTT, here one RTT, or in special cases as we discussed earlier, we can establish zero RTT also. These are some evidences which I captured in Wireshark. Thank you.